Thank you, Paul. 谢谢. 大家好，我是 Jason. 我的普通话不好, so I have to speak in English. We've all seen and heard a lot about AI over the last few years, and indeed, it's greatly expanded in the last few months. But whenever this happens with a technology, it's easy for its value to be lost in the hype. So at Google, we want to be helpful in making AI clear for everyone. And we'll start with a definition. We like to see AI as a concept. It's a way of programming computers to react to data in much the same way as an intelligent being does. So having a computer understand the contents of an image or sentiment in a sentence, for example, makes it intelligent artificially. Now, machine learning is the technique that we can use to achieve this. Simply put, we use lots of data, and we train a computer to understand the patterns in that data. What makes this picture contain a cat, or that one to contain a dog? Or what makes this sentence contain a positive sentiment, or that one contain a negative? By looking at lots of data, a machine can learn about it. So when seeing new data, it can intelligently predict what's there. And thus, machine learning is a technique used to build artificially intelligent solutions. Now, this technique has been made available to all of you through open source technologies like TensorFlow and JAX. The global population of software developers is about 30 million. Many of the world's largest companies are dependent on developers. And indeed, it would be hard to find a company that doesn't use software engineering somewhere in the stack. To date, about 10 to 15% of developers have skilled up with machine learning. They're already beginning to transform their businesses using artificially intelligent solutions. There's also a growing number of developers who are using AI solutions without building machine learning models. And keep an eye on this group, because today, app creators must be trained developers. But tomorrow, that might not be the case. And we'll look into that more later on. Now, Janine shared Project GameFace earlier. It's a solution that was built by software engineers, just like all of you. And it did something that I believe is amazing. But it's also a nice reminder that while AI can be a powerful solution, it's not magic pixie dust that does everything for you, but actually a tool that, when used by a good engineer, it opens new doors for solutions that are previously impossible or infeasible. So for a problem like this one, machine learning models were mixed with good old-fashioned software engineering to create a solution. First, AI was used to detect where in the frame the face was. It's not always in the same place, and it can move around. Next, code was written to cut it out. Then another AI model was used to figure out common anchor points on the face, like the eyes, the nose, the ears. In fact, almost 500 anchor points were used. Finally, code was written to turn these into movement. Additionally, more models could be used to detect blinking, smiling, and so on. As you can see, AI isn't a replacement for what you do as a coder, but it's another tool for your toolbox to help you build better applications and potentially explore things that just weren't possible before. Now, let's look at machine learning engineers, the folks who actually use the data to train AI models like the ones we just saw. For example, data about what a face looks like so you can detect it in an image. OK, so first, I'd like to talk about some of the new tools that have become available to you in the last few months. The goal for good modeling is a three-tier stack. Start with a framework for easy model definition and iteration. As you code machine learning models, you need to test, iterate, and so on and so forth. And Keras is your friend here, as it's always been. At the bottom of the stack is where you need your models to execute, and a runtime that's optimized for every platform. And this is the strength of TensorFlow. It can run on so many platforms, from the smallest microcontroller all the way up to the largest cloud. Now, in between these, a hidden layer, if you will, is where the heavy lifting of machine learning actually happens. It's where the parameters in your model are set by tuning them from your data. And we've learned that developers love optionality here. So we've made the stack compatible with TensorFlow, which of course you're familiar with, but also JAX, our framework that lets you do advanced math for machine learning really, really fast, and is used by Google and DeepMind researchers for our state-of-the-art machine learning models. as well as PyTorch, and potentially future frameworks for machine learning. Now, what's really exciting is that regardless of which framework you choose to use, your code does not change. And that's Keras Core, open source, multimodal, and ready for you to use today. Now, I want to return to the model users I spoke about earlier. Today, you have to write code to consume models on various platforms, as we just showed, but chat apps with large language models have introduced a whole new breed of model user to the world. What's particularly exciting is that they don't have to be coders to be able to create solutions, and as such, the population gets larger than today's developers, maybe even much larger. So what would a world look like if there's 300 million people who can build stuff using machine learning instead of just 30 million? What new solutions or businesses could grow from the work of software developers and model users working together? So at Google, we've made it our goal to be as helpful as possible to this new population. We're learning and improving over time. But I'd like to show you some things we've been working on. Model users can interface with language-based models using prompts. But prompts can be more than just simple questions. You can take them a step further using a process called prompt engineering to create applications. This allows you to use plain language to get a model to do whatever you want it to do. And prompt engineering is an art form. There's no one right way to do it. The most important thing is to be creative and experiment to find prompts that work for all of you. So we've created MakerSuite to make this job even easier. And here's an example that creates an app to classify if a sentence is positive or negative. Instead of writing a lot of code, I gave the large language model some examples of text, along with their classifications and how I wanted them to be presented. I only needed 3 or 4 examples. And then the model was smart enough to figure it out. So when I give it new text, it does the job for me. Now, think back to how difficult this might be if you were to write something like this all by yourself without using a large language model. And once done, perhaps, I could work with a coder to turn this into a product or service. In fact, these models are what we use to power many of our products today. Take Gmail's Help Me Write feature to create email drafts based on simple prompts, or the Magic Eraser feature in Google Photos to detect distractions in your photos and remove them in just a few taps. You can see the potential to revolutionize product development by enabling millions of people who do not have traditional development or data science backgrounds to bring their personal experience to build whole new classes of applications and businesses. And this is what we want to bring to all of you. You can be the dreamer, the maker, the thinker, and the shaper to harness the power of AI and solve problems and build solutions that help us all. Thank you, and xie. Let's now hear from Ting, who's from Google Cloud, and see how they're innovating over there. Thank you.